Hello and welcome to the HCD robustness meeting. Today is March 26th, and one of the topic I wanted to bring as there a couple of people is the antithesis engagement. There was I think this was discussed on a couple of previous meetings or mentioned, but now we have the final confirmation. Where is it? Oh, there is an update, or maybe I would need to find an issue. The issue. Don't remember where is it. Okay, maybe I can find. Yeah, so I think that the current status is that we will bootstrap the work a week after KubeCon. So that's 7th of April. So that would be a separate meeting. I don't know if that's. I think there was an invite sent to the HCD dev group. I don't know if the time proposed is best for everyone that is interested in the topic. Alternative would be to just host the antithesis engagement during this meeting, but I wanted to first hear people out. Okay, if there are no concerns, I think we can go with the current date, current invite. So please confirm that or double check if the date is okay. I don't know if I have the meeting. In my calendar, no. So not on this. Okay, so let me quickly do the notes. Right, meeting. I don't know. It's the time hard to convert the. Yeah. Yeah, so anyone that is on the mailing group should get an invite. Let me just confirm it on the phone. Maybe I'm not subscribed on the. Okay, it's a short-term meeting. It will be hard to calculate the time. Yeah, for me, that would be how many? Like 3.5 hours early. So I don't know. Yeah. Okay. If there are no concerns, then we can just move on. I think then we will discuss how we should start the project. If you're interested, there should be an issue. As I mentioned before, I can just paste the links so everyone can take a look that don't have full context. Yeah.
So I don't think I've ever seen the invite. Anybody else seen it?
Nope.
Maybe it was not accept. That's a good. Thanks for mentioning Siwan. I think what is missing. I think there might be an email that is not accepted, but I haven't seen. Let me double check.
Hi, Mark. Hi, I'm Lori. Marcus and I work with Antithesis, just listening for this one. But if you let us know, Mark, if there's a better email address we can send that to, just let us know and we'll get Craig to send it out.
Yeah, that's the correct email address.
Okay.
It's just.
It got eaten by the Google group or something, probably.
Yes, I assume so. Let me.
Okay.
I mean, I can.
We'll make sure that it gets sent out. So.
Yeah, that would be good. Let me just double check the group. Oh. Public. Yeah, I wanted to do it early because then we will not. If this doesn't go through, oh, there is a pending. So. Oh no. So okay, I will need to think why this meeting didn't go through. I think we can do a temporary solution, which is just ask people to put their emails. I don't know if that will work. It's here. Yeah, the email. The invitation is present, but it didn't send any emails. I'm not an expert, so I think we can. Is there? Okay, so we have two options. One is either start asking to contact you directly, or try to figure it out.
I think we can, we don't need to figure it out right now. We'll either put an invitation in the Google group, or we can work with you, Mark and Craig, offline to make sure the invitation gets sent out correctly to people. If anyone wants to let us know right now, I guess on that GitHub issue, or I don't know, the best place for people to show they're interested. Mark, do you think it's the GitHub issue? Or
Yeah, like the main communication should be the GitHub issue. I'm just
okay.
Know how they will contact, or
Yeah.
how you
I
just send the
can
invite.
Yeah, I can put, we can put our email address in that issue and have people contact us if they want to be added to the invitation. And we'll work to make sure, to see what's going on with the googlegroups.com invitation. So we'll try a couple of different ways to make sure that you all have access to the right calendar
Okay.
invite.
So, can you add maybe an email, or you mentioned how to contact
Yeah.
you?
My email address, so LAWRIE.
Sorry, I'm not the
No,
best.
that's okay. It's an awkward name. R
R
I
I or I
I E.
E.
Yep, correct. Dot. No, back to E. Yeah, dot. And then the color green in English, GREEN, at antithesis.com.
Okay.
Yes. So
So
email
please.
me and we'll get you set up.
Okay. Are there any questions about the engagement or any other questions related to robustness? If not, I think we can proceed. Maybe just close the previous. I don't think there are any new issues related to it, to robustness. So we are good on that front. There is some work happening by Henry, but yeah, so there is some progress, but we haven't. There is no direct, no new issues reported. So let's look at the test grid. Maybe I can scale it up. So since for the last 2 weeks, we had 2 flags in AMD 64, 1 flag in ARM. On 3.5, we had 1 flake on AMD, no flake on ARM. And that should be it. Okay. So let me copy all the links. For that. And let's try to root cause it. So we have 6 links and there are 6 tabs. So first issue here, it's related to the QPS. So there was some previous discussion and the issue about the I filed an issue, if you haven't looked, to investigate the improving the disk performance on the QPS. So we have one, and let me find the tracking or assign it to the issue. So second one, it looks like the same. And third one. Ooh. That's an interesting one. So let's leave it here and quickly look at check the other ones. We have another low QPS, another low QPS, and another. So yeah, we unfortunately we need to sieve the issues from the flags. So we have a new type of issue, and let's look at it. So yeah, I haven't seen this issue, unexpected differences between wall entries. Okay, I haven't seen this issue ever, so I would need to start from looking at the code. So let me stop my sharing and share it once more. Can share entire screen. And this So issues related to unexpected wall entries or diff. What is this? This is other projects. Mm. Let's look at master or main branch. Some drafts. Okay, so this is part of the etcd patch or like patching logic, let's say, to make the linearization faster. We do a little bit cheating. So normally when you're doing linearization, you try to treat the database as a black box. This black box, you just try to observe your inputs and try to look at the responses. But this, when linearizing, can be very costly because you cannot do any assumptions about what is happening inside. And if you have many concurrent requests that you or linearization requires you to find order of requests, and when you have many concurrent requests and you don't know the order, you basically do very exponential, like 2 to the or 2 to the power, yeah, like factorial complexity for to find all the paths, like to validate all the possible paths for correctness. So this is something we avoid by looking up the data, picking up it inside and checking what is happening at CD. And usually it works, or this is first time I've seen this fail. So that's an interesting thing. And there are two things that interest me. One, why it happened, and second is, does it fail before or after linearization? Because like differences in wall are very difference in wall is very suspicious. Like it means if everything in the test itself or like the logic that extracts the data from etcd is correct, it means two different etcds persisted different records. Technically here, maybe one thing that is interesting is this is the last requests in the sequence. So because there are 922 in identical elements, and then there is the one that is different, and then there is nothing. So if you by reading the diff, we know this is the last one. So the only or one thing to keep in mind is etcd doesn't necessarily commit, like when it writes to wall, not everything that is written to wall is necessarily committed, and two members could be or during cluster disruption, two members could be in disagreement about what is in the wall. And that's why we select a leader. And what leader does is he just tells everyone his way, and he asks every other member to remove to change their history to history of the leader. That so here I'm thinking that there could be a possibility of this entry being in the uncommitted state, and there could be a bug in the logic that reads the wall files and just read too much. That's the only situation, that would be a case where there is a bug in the logic that reads. What I've seen a message. Can you let me follow up on it, or have or okay. So I think I just can you see my screen? Is it readable?
Yes.
Okay, so I'm showing the. Okay, maybe there was no message. Yeah, I'm showing the wall diff. Is it readable? Should I zoom in?
Yes, all good.
Yes.
Okay. Okay. So yeah. So when you going back to the topic. So this could be either a bug in etcd or bug in a test. That's always good to consider. A bug in etcd would mean we wrote different members don't agree what is the last entry, and bug in test would be when trying to consider and read walls, it read the uncommitted entries, which technically mean that we not necessarily they could be our assertion that they should match is not necessarily true. So let's try to figure out if this is correct. So how we do it? We download the report. Okay. I don't like that. So when we report should include all the information that is interesting for us, including things like all the black box input and outputs from communicating with etcd, but also the the state of the wall. So we just copy the whole database and wall and put it into the report because now we can debug it and look directly. We can use the built-in tool to analyze it. So I'm looking for the directory called test data. Yes, this directory. Can I open the folder? Okay, so I can copy the report into the directory, and this allows me to analyze it or use automatic existing script that will run the tests. There is a already existing test method that will look up the reports in this directory and allows us to quickly reproduce the issue. So this can be done by and here is one great improvement by Ivan. Now you can run or I can even show you. You can run the tests. I don't know if this test works. I hope it does. Now you should be able to run the robustness testing from two directories. We have, or Ivan has updated the make files in a way that allows us to run from any directory, or at least those two, from not only from the root directory of the project, but also from the robustness test directory itself, which was one of the not great user experience before. So yeah, the test run reproduced the same issue. So what we can do, my first approach is usually this process is part of history patching, which, like I meant, which is the process I mentioned that we peek under the hood and try to look up if there is anything bad with the report. So let me think. I think it should be enough that we disable the operation or disable patching, because we cannot patch technically until we know what is the source of the truth. And we need to disable the reading of the file itself. So this should be in validate test, data reports. Yes, so this is the test that loads the thing. This loads the client reports. Maybe what I was looking for this function. Are we calling this function? Find all references. Or where are we calling this function? Dot cluster persisted. Okay, maybe the references. I think there I have my IDE doesn't work today with me and doesn't find the references. So yeah, here we are loading the cluster persisted requests. Because we technically don't need those requests now when we are not patching. Let me just pass a nil here. I hope it works. Yeah, because it's persisted. This should work, and just disable this. Yeah, and if we have persisted request nil, near this part of the code will not work, but let's not care for now. Okay, we have this, which is validating some assumptions. Yeah, fortunately, it's not easy to disable this mechanism for now. And my favorite thing about Golang, you cannot change code or comment out code. It will not like you. Okay, so my goal was to validate, can we linearize the response? Why? Because we can, this gives us the visualization and easy answer that might, like in most cases, linearization is fast enough to find the result, and patching really is needed only in the extreme cases. Here, so linearization for the good cases can take around a second, but in the worst cases can take tens of minutes. So current strategy is we always try to patch the history to ensure that or just to go through this path and just to save cost, because we don't want to wait tens of minutes. Maybe one improvement would be to not patch if there is no need. So we could potentially try to run the history or linearization for, I don't know, 1 second and see if it exits. If it finishes fast enough. I think that there is difference in errors, and only patch if it doesn't work. But here, here even linearization on my laptop, which I suspect is still faster than CI, takes 4 seconds. So just to iterate faster linearization is I always enable patching, or I propose to always run patching to have fast run on CI, because running robustness takes just a couple of seconds, and we want to run hundreds of them, hundreds of iterations. So it's pretty. It would be pretty wasteful to always wait a second and never without patching. So yeah, to give you reason, or this is a nice example why the patching is important. Is we started from this number of concurrent requests, and linearizing here those, I don't know, 7, 8 concurrent clients is fast enough. But at some point when the requests are failing, we cannot consider, or it's hard to know when the failed request has finished. So we don't really know when it finished. So number of concurrent requests that we need to consider grows. And when factorial of 8 is still pretty acceptable, like I know it's a couple of thousands, I don't know, like 120 times 7 times 8, so still thousands. Factorial of 16, I think here is too much. Yeah, like I think it's 13. So that would be much bigger number. So we just cannot pay it. So so here, this directly factorial linearization past directly points to the bug in a test. So let's try to find the bug, because all the changes were just to disable. I can just turn them back. Yeah, I can just revert the changes I did and try to figure out why there is a difference in the why there was a difference in the wall, or the different, or technically the guess, based on the current guess, that would be why the uncommitted wall was included when reading. So I want to quickly just jump to this function, so I don't want to, sometimes it's harder to find it. Okay, so this reads a wall. This calls read wall, then makes thing and removes some data entries, not normal entries. I don't think we are interested in other types entries, and see the read wall. Okay, that here, I don't think this function needs to. This is pretty low level function. I think it's copied from the main etcd wall thing, and here we have the messages. So I think we can entries. We can just do it. So what is the problem here? Parse entry. We need to identify the committed entries. So here we are just looking at the normal type of entries. We are parsing them. And here the problem is that, okay, so yeah, I'm pretty sure this is the committed issue. The reason is, I think I was lazy and then forgot that happens, is fact that type of entry, etcd proto entry type, okay, entry type normal. So commit in etcd, commit is a separate type of entry, but I don't see it. So maybe let's go parse entry normal. So maybe it's within here. It's what is okay. So this is after parsing, and this parses to HTTP request internal draft internally correct request. Okay. So here is the raft entry that an internal raft entry that encodes all the information. What I'm a little bit baffled and I don't remember is how we mark the commit. So let me cheat a little bit. So here's the wall code. Here's the wall function. And no, this is direct. This is open for read. So this is the etcd server, the storage code in the server for opening the wall. I don't want the wall. I want to read the code for committing wall. So this is read all. This is valid, and this goes different. This is verify. Cut function sync. Sync is sync. Sync just flashes data to the disk. And close. Save state. So hard state, yes. So this is how etcd commits. It creates a record of type hard state. Remembers where's the thing and encode record. Didn't remember record. Okay. So when we want to save, we write a hard state, but how do we know? So record type is handled on the lower level. So read all returns as their last. Okay, so this is a problem. And read all will or commit information in the wall is not returned as entries. It's returned as a separate record of or different type of record, which is just read all return from wall returns as the last hard state it noticed. So here the hard state is updated only, should be updated. Yeah, state type. So here the state, I know why I didn't highlight, is only recorded when we encounter the last one, or only is updated on the loop, and then when we return the last hard state. So hard state includes information about the commit, which is a commit, should be a commit raft index of commit entry. So so then how do we handle this? We need to we read all the entries and we ignore the state. So here is the state. That's the missing thing. So if entry index is greater than state commit break, such easy code, or such trivial thing that I left. Maybe not. Okay, so that didn't work. That's interesting. Maybe it wasn't as easy as I thought.
I checked the log, and there is about the 2,000 items. So I think that is not the last one.
Okay, so you're saying we have 922, which is just a small subset of the
Yes.
2,000. That's good to know. The problem. So here we are hitting. Let me. So now, if we don't know what to do and simple solutions don't work, we can go to the search. So one common thing is, but I don't see it. It's good to remember that etcd does a wall cleanup. So we are a little bit abusing the truth and simplifying the word, is that I assume that wall includes all the information during the test. And it's usually true, or should be true in most tests, but because etcd wall allocates, let me think, 64 megabytes of data with zeros, or it's always the wall file will always have 64 megabytes, and it will, or something like number like this. I can double check, and it will only use the file, and etcd will continue to write to it until the 64 megabytes is used. Yes, exactly 60. So it's exactly 64 megabytes because this is pre-allocated space and filled with zeros. And sometimes, so if this 64 megabytes we exceed it, we then create another file, and we create this will continue until there's, like, I think 5 files, let's say, plus minus some additional logic, and then etcd will start cleaning up the old files. So there is a chance that we don't have full wall. So that's always good to consider. But here we have all the etcd servers have the same, have single file that is called by almost zeros, and this is because this is the I don't remember now what's the coding. I think it includes revision number and something other in the name. So this basically, if there's only zeros, it means this is the first file in the sequence. So both are empty. So at least it's also surprising that why why there are more entries. Maybe other possibilities. I just in the diff, I only read the entry normal, and there are other types of entries, or there could be, or also there is a logic. I also ignore a lot of types of. So maybe other reason is in the test we ignore other types of entries because they're not relevant. So here, for example, we don't read cluster version setting, downgrade information, membership information, because this is not needed for the linearization. We only consider the key value requests. So, but it's a worth thing to remember. So there is one file. Maybe let's just read it. So for simplicity, and because I don't remember all the tools, but maybe it's an easier reference in the document. Okay, we will read the documentation as in the markdown. But one of the things that is described is how to analyze the wall files. So what we need is to here is the documentation about the files and how to do. And here is mentioned the tool etcd dump logs. So let's run. Have I used it? Etcd dump logs? No, no, no. Yeah, no. So it should be go tools, etcd dump logs, main. Doesn't compile. That's okay. We still didn't. We haven't yet. Ivan, we need workspaces.
No.
No, okay. Don't tell me I will need to. Also, will need to help do it, but that's also okay. Okay. Oh, that's a very nice thing. Yeah, that's not super readable. The reason is in the robustness test, we also test big things, big responses. I'm thinking, can we filter it out? I don't know. Let's say only normal. How to remove? I could try to grab to remove the letter, but is it easy to write? How would you remove the letter? Or I don't know.
What do you want to keep?
I
Remove?
want no. I like there are two types. If I filter just the normal entries, there will be two types of entries. There will be like entry that uses a small key or small value, and there will be write with a large value because we also test if there is, I know, any data corruption or whatever, like if etcd doesn't do correct writes. So we also validate a very large value here. For readability, I wanted to remove it, but maybe we can just live it with it. So yeah, this basically flashes all the 64. So yeah, so this is all the entries, and looks like we have 2000. All the highest raft index is 2936. We have maybe we have 934 entries of normal type, which is the writes to etcd. Let's say modifications, and what else? Can I recognize? Does it mark commit or hard states? Grab commit. Oh, and here it's okay. It also writes at the end the commit index. So we have so here I don't remember the. So here the commit index is ends with 35, or I just can do tail. And the last entry, or maybe this is nice, but no commit. So last entry ends here. So this is uncommitted. This is interesting. So this says the commit index in the wall is this, and this is, and that would point to this entry. So there is one uncommitted entry, and it's called tombstone. It's just a thing that robustness does right at the end. We can do the same for the second. So here, situation is the same. We have same number of entries and same commit index on the second, and on the third server has the same number of commit, same commit index. And sorry. And it points to the same thing. So all is the same. Why the function is returning something different? Any idea? Anyone is also like, I like that there is other investigation going on in the background, so we can look at different perspective. This is key 7. There is a change in key 7. So this. Or key 7 or key 5. Oh, sorry. So in one wall, we read totally different data. I think that the only thing that is left is debugging. We have still like 4 minutes left. I don't know if we will go farther. Much further. Okay, so how to debug it? I usually just do simple stuff. So so let's say this didn't turn out. So let's say wall zap, and say we have int and commit and state commit index. Okay, so it will transfer. And zap, how do you do any? Oh, any, exactly. And last entry state, no. And len of n -1. So we would expect that ooh. Oh, so yeah, we have wall that finishes on, oh, so we have one wall that is marked as slice bounds out of range, current entry. So looks like the problem was I skipped this message that had an answer why happened. So here, slice bound of range implies that we're not able to read all the wall. Snapshot, this is reference to 0, 0 is a reference to the beginning of the wall, and this is when you request to read a wall in etcd. You need to provide the snapshot, and this 0, 0 means we want to read from the beginning. And here it says that it was not able to read it. So so basically, those two etcds were correct, but the third one, some logic didn't work for it. So here, so this is the error. So for some reason, we are able to read wall from from two members, but not the third, but still the tool for the dump logs works. So that's an implication. So what I would, we are out of time, but just to summarize, we looked at the possible causes of the failed tests. We investigated the diffs. It turned out there was difference in wall. We eliminated the chance that there is an issue with the etcd by checking the linearization and just disabling the validation that we had. We found that etcd behaves correctly, but the logic that reads wall failed. We confirmed the wall contents using the db dump to dump logs to returns the same values, and so it works at least correctly. But the logic that runs in robustness tests doesn't match the values. And here we are, I think, swallowing the error. I think that could be copied from the original etcd. I don't remember. Here it's just case that etcd can accept these errors, but we don't want to, but apparently this returns incorrect wall messages. So I think the next steps would be good to understand why there is, why the dump tool logs can read the wall and we cannot. Fix the bug in the reading the wall so that we don't swallow this error for some reason. And third would be, I think that's the issue with this hard state still stands. I think it just doesn't happen because we give etcd enough time to shut down and there is no race with commit, or there is no issue with the commit or entries not being committed. So that's, but that's still a possible improvement. Yeah, that should be all. Sorry for taking additional time. Hope that was helpful. If, yeah, I think we can finish here, and let me know if it makes sense. Was it helpful, or what? If anyone is interested in working on one of those issues. If not, no pressure. I will post the bugs in the on the GitHub and try to describe what we done here, and maybe someone can pick it up. Okay, thank you all for being here. We'll finish for today. Hope to see you. The next time will be, hope to see you on KubeCon if you're going there. There is a KubeCon next week, but hope to see you in 2 weeks. Is there a question?
Yeah, Mark, I would love to jump on the issue, but I just don't think that I have enough context. I would like really help. I would like really appreciate if somebody can help me through with it.
Sure. So the issue, I will try to write an issue and provide all the context. Okay. yeah, thanks everyone, and hope to see you in 2 weeks or a week if you're attending KubeCon. See you.
See you.
See you.